Look at the unit. Look at the x and y axis.
It's just flip.
So the natural log of a versus time looks like this. The 1 over a versus time is positive. If it's just the concentration versus time, even if it's zero order, it doesn't affect the rate. The concentration will decrease in a reaction. So if we have A versus B, so I just want to be clear here, I'm going to try not to confuse you, but even if this concentration doesn't affect the rate, it will decrease over time. So I just wanted to explain that. So zero order doesn't mean nothing happens. It means the concentration doesn't affect the rate. So what does? Maybe a catalyst, an intermediate, something to that effect, which we're going to talk about in a minute. I'm not too worried about it, but just remember, natural log is first order, 1 over a is second order. The only other graph they could give you is zero order. They're not giving you a third order. That's not even something that we talk about. So, look at that practice problem I just gave you. Look at the chart. It says initial rate study was performed, data experimenting, using the information, what is the order with respect to each of the following? So I'm just going to go through this again really quick because this applies to any problem they could give you. The only difference is it'd be different numbers, different reaction, but it's the same method every time. So if you want the rate with respect to Cl minus, what we need to do is find two trials where Cl minus changes and MnO4 doesn't. Now the H plus is just the acidic medium. It's not really a reactant. That's why it's the same for all three. So what I would do here is I would take trial 2 divided by trial 1. And I would take 0.0312 divided by 0.0104. So rate would equal K times Cl minus concentration times MnO4 minus concentration, X and Y. So we're trying to figure out those exponents. So this is to the X, this is to the X. Equals 2.03 times 10 to the negative 7 divided by 2.25 times 10 to the negative 8. Technically, I wrote this backwards. It should be rate equals concentration. That doesn't really matter. But this should technically be here, and this should be there. So what we're doing is we're dividing these numbers, solving for the exponent. That's the order. So when we divide these, I believe this was a 9, and this is 3. So X is 2. So with respect to Cl minus, it's second order. I can look it up really quick, but or you can just use your calculators fast. But this is how you do every single one of these problems.
Yeah,
They give you that's right?
yeah.
Okay. They give you these this information, these charts, and you always take 2 of the trials where one is held constant, the other one is changing, and solve for the exponent. Now, it could be, they could do this on a multiple choice, but they would have to be numbers you could do without a calculator. I feel like we've done a decent amount of those, so you guys, I feel like, are ready to do that. You just have to be careful and pay attention to the powers of 10, or however you want to do it. But again, this divided by this is 3, this divided by this is 9, so that must be second order. So for the first one, Cl minus is second order. For MnO4, I would take trials 2 and 3. So I would take, this time I'll do it correctly, trial 2 divided by trial 3, it's 2.03 times 10 to the negative 7. I always put the bigger number on top because we don't want to mess with decimals down here. Divided by 1.02 times 10 to the negative 7 equals 0.004 divided by 0.002. And this is going to be y raised to the y. I believe they're both 2. So y is 1. So with respect to MnO4 minus, it's, I know that's 2. That looks like it's pretty much 2. So y is 1, so MnO4 minus is first order. So that's really good to review because this again, is any problem they give you with a chart and they're asking for orders or rate laws, this is how you do it. Questions? I hope they have one of these. Hope you feel the same because they give you the information. As long as you remember what to do, shouldn't be a problem. Okay. So now we know the order overall is third. You might as well just keep going on this page here. Rate equals K times CL minus squared times MnO4 minus to the first. So it's third order. Now they want to know the rate. There's your rate law. So that's the answer for C1. C2 is calculate the rate constant. How would we do that? Now that you know the rate law, pick any reaction. Trial 1, 2, or 3, plug everything in. So if we take the first trial, this is 2.25 times 10 to the negative 8, divided by CL minus 0.0104 squared times Mn 0.004, and that's K. But now it says include units, right? Yeah. So it's third order, so we know it's M minus 2, S minus 1. Hopefully we remember that. So usually you get 2 points here, one for the answer, one for the units. That's usually how that works. So I'm going to look this up again. So give me a second here. And then think about part D. Once you get that answer. Which leads us into the next thing I want to talk about. What did you guys get for K? Anybody?
0.052.
Yep. Okay, good. Now, hold on a second. I want to make sure. Oh, I missed C. What did I miss? Read question C. I went too fast. What's it say?
Respect to H plus.
Yeah, it gives you H plus. See, most questions, they won't give that to you because it's the medium. So that's not part of this, but they're telling you it is. So the difference here would be you'd have to throw 3 cubed in the bottom. I missed it. The way you do the problem doesn't change. I just went too fast. So part C, it gave you H pluses to the third power. So this would be the answer to the rate law. Okay? Don't do that. Don't go too fast, but I'm trying to get through as much as I can. So that just changes. You have to just throw in one more number. It doesn't change anything we just talked about. We just have to put that in there. Okay. So, again, once you get your orders, how do you do it? We went through it. This one they gave you. You just plug in numbers from trial 1, solve for K. Now, of course, on an AP test, they will do this. This changes our unit on K. I might as well talk about it. If this is a 2, and this is a 1, and that's a 3, what's that add up to?
6,
6. So what does this have to be?
5.
5. Yeah. Of course they're going to do that. Thanks, guys. Thanks for never having any practice problems in any books or anywhere else of a 6th order reaction. And then putting it on a test. Actually, Mr. Whitfield and I were talking yesterday that a lot of times in college, especially in his area, history and in the humanities, a lot of times professors will just lecture about random things and then give you a test on the stuff in the book but never refer to the book at all in their lectures. So the test has nothing to do with what they talk about in class. It happens all the time in college. Less in chemistry, but so we look forward to that. So, what do you guys think about D? And this is what Skylar was asking yesterday about the steps, so we're going to talk about that right now.
No.
So if you look at this sheet that Cal and Tristan handed out, it says step 1, step 2. Just Cal. If you look at this, that's what they're talking about. You have these elementary steps that make up overall reactions. We're going to talk about this next. So they're saying, okay, now you know the rate law, you know the K. Is it likely it occurs in a single elementary step? Justify your answer. What do you guys think? This is hard. This is a hard question for you to come up with. You seemingly like out of nowhere, right? How am I supposed to know this?
No.
Yeah, I would say no, and the answer is no, but why?
Because there's 3 different things you need to find. There's 3 different concentrations which need to be.
There's 3 different reactants.
Yeah.
That's the first thing I would focus on. So if a reaction occurs in one step, that means that all the effective collisions occur in one step. That's pretty unlikely if you have 3 reactants. Think of the combinations that could happen, right? So that is what I would write. They put, where am I? It's not likely the reaction occurs in a single step because the orders of the reaction with respect to the reactants do not correspond to the coefficient in the balanced equation. That's what we're going to go over. It is not likely that there's 2 answers. It occurs in a single step because the reaction requires a collision of many reacting particles, and the frequency of the many reacting particles is negligible. But they're talking about something kind of more advanced we don't need to really get into. But the point is, the first answer I'm going to explain in a minute. The second answer is what I would have written and what I'm explaining. If you have 3 reacting particles, it's really unlikely they're going to all collide the way they need to in one step. There's just too many reacting particles, too many collisions. So that is one answer. Now, the coefficient business, what that means, if you look at the top, if the elementary steps occur in one step, that elementary step is the entire reaction. So the rate determining step is the reaction, if it's just one step. Since the 8 in front of H plus, the 4 in front of Cl minus, and the 1 in front of MnO4 minus are not the exponents in your rate law, that can't possibly be one step. That's what that first answer means. And I'm going to use the next paper here to explain that a little bit more. So let's go to that other one. So the one with O3 plus Cl plus O2 yields, or plus ClO. Here we go. Let's do this one. So if you read it, it's talking about ozone. It's in equilibrium with O2 and O, but the proposed mechanism, there it is. So write a balanced equation for the overall represented by step 1 and step 2 above. All right. So how do we do this? What do we do?
Combine them.
Good. But what do we do?
Cancel out the, what are they called? The things that are similar.
Okay, or the same, or we'll call them the same. Things are the same.
Yeah.
Yeah. Go ahead. So let's just do it out loud. What would the overall equation be? O3.
O3 plus O yields O2.
Right. O3 plus O yields
2O2.
2O2. The CL's cancel and the ClO's cancel. Clearly identify the catalyst and the mechanism above.
That thing. That's what I was trying to
A catalyst is never consumed in a reaction. You use it in the beginning to speed it up, and then you can take the catalyst out at the end.
say.
So it's Cl. What's the intermediate? ClO. So when you have these curves, and remember, sometimes they do one of these guys. This is going to be your intermediate. So the catalyst would maybe lower this activation energy, so that's what the Cl would do, but the ClO would be the intermediate, meaning it's formed at some point in the middle of the reaction, but then it reacts and it's consumed, it's not a product. So neither one of those, catalyst, intermediates, or products, the catalyst must be with the reactants initially. That's what it helps it react, and then you're going to take the catalyst out at the end. It's not actually a product. The intermediate's similar but different. It's not there in the beginning. It's formed kind of halfway through when these collisions start occurring. Then it reacts, and then it's gone. So that little dip is where the intermediate would be. A catalyst, where you wouldn't label the symbol, but that's what the catalyst does, lowers the activation. So I know Skylar asked that yesterday, that's exactly how we do it. So the catalyst will always be in the beginning of step 1 and always at the end, because it doesn't react. And the intermediate is formed and then consumed, so it's not going to be found in the products. If you look at the rate law, it says if the rate law for the overall reaction is found to be rate equals blah blah blah, determine the following. The overall order. Alright, so if that's the rate law, what's the overall order? 2. What's the units on K? N minus 1, S minus 1, as long as there's time involved, or S seconds involved, it doesn't really say. So, the rate determining step. This is how I'm relating it to the last question we did on the other sheet. The rate determining step always matches the rate law. So it's got to be step 1. O3 and Cl are in step 1, that's the first clue. But the coefficient in the rate determining step are the exponents. So, again, it's hard to just make this stuff up, but sometimes what they'll do is they'll give you 2 steps. So just to show you what I'm talking about, I don't know. Just stay with me. Let's say this is step 1, step 2. It makes no sense, but just stay with me. They give you the rate law, rate equals K times, so the one they give you, this one must be the rate law because this is raised to the first power, this is the 1, this is raised to the first. If this was the rate law, CL would be squared. So I've seen questions where it's not as easy as this. This one's pretty easy because step 2 doesn't even have the right reactants in the rate law. It has to be O3 and Cl, so it has to be step 1. But what I'm trying to emphasize is the coefficients are important too. So if the rate law happened to be Cl squared, then in this up here, it would be rate, or step 2 would be the rate law. Rate determined, sorry, which is the slowest step. Am I making sense?
Mm-hmm.
Okay. All right. We've been doing a lot with this kinetic stuff right now because I think it's good. It's good to review. We haven't done it in a long time. Hopefully it's ringing bells and you're feeling comfortable with it. All right. So what I'm going to do is I'm going to try and find, I can't guarantee it, I'll try and find a first and or first one of the 2 second order problem where you have to use those equations on the reaction sheet. I could give you one in my notes, but I know we really want to do the practice AP test question. So I'll try and find one. The only advice I can give you right now, in case I can't find one, those 2 equations, so the natural log minus natural log negative KT, those 2 equations, the big difference there is the first order half-life is always the same. The second order half-life changes. So first order, that natural log equation is for like nuclear radioactive decay. That they could use a radioactive decay in the question. You don't need to necessarily know about it or like fully understand it to answer, to ask a question using that equation. One thing I will say, and then we're going to talk about equilibrium here, is typically what they do is they'll say, okay, it's first order kinetic. They might tell you it's first order kinetics, and it says the half-life of the substance is 20 years. Calculate the rate constant. So they hardly give you any information. So when you're doing this natural log minus natural log T0 negative KT, they give you T, and that would be 20 years. You're solving for K. If they don't give you concentrations, but you know it's a half-life problem, what can you do?
2 and 1. Or
2 and 1, 1 and point. Sorry,
half of it.
this is the initial. That's the other thing I'm glad I just remembered. You have to remember A sub 0 is the initial, so that would be, let's say, 1, and this would be 0.5, or 2 and 1. So T is at time T. So after 20 years, you have half of it. Sometimes they give you percentages. So they say, you know, it's first order kinetics, the half-life is 20 years, you know, calculate how long it takes to decay for 25% remaining. So you'd have to solve your K first, then go back and use this again. I know this isn't that helpful, but I'm just reminding you, you can make up numbers if they don't give you concentration, but they tell you the half-life. Alright, so I'll try and find one. They're not super common, so all the other stuff we just did is much more common. Alright, so hopefully we're feeling better about kinetics. Any other questions on kinetics you can think of, something I mentioned or talked about that you want help with? Okay, so I'm not going to go over the Chatier's principle. Yeah, so just maybe I should just take like 2 minutes and explain it really quick. The only thing that might be confusing is the volume and pressure. So if you have gases, so I will talk about this quick. Let's say you have 2A and then 1B. If this is at equilibrium and you increase pressure, which way does it shift? Increase pressure. Shifts towards the lower number of moles. Decrease pressure towards the higher number of moles. Okay, what if the volume on this container is decreased? I want you to think of volume questions with respect to pressure. So pressure, temperature, and volume. If you're decreasing the pressure, or volume, your pressure goes up, right? So if you shrink the container, it's going to increase the collisions because there's less space. So if you decrease volume, you're going this way. If you increase volume, making the container bigger, let's say, then you flip this. So when volume goes up, pressure goes down. So now if you decrease pressure, you're going back to the left. That's the only part I think I need to really just remind you of. I guess the only other concentration changes are pretty straightforward. If you add more, it goes away from it. If you take it away, it goes towards it. What if it's endothermic? So if your energy is here and we decrease the temperature, what happens? Shifts towards the energy. And if we increase temperature, it's like adding more of this and we go that way. The other, from the thermodynamic standpoint, if you have an endothermic reaction, it'll work better in a hot environment because you're giving it energy. Right? It's absorbing energy to react, so if it's a warm environment, it's going to react better. And if it's exothermic, if the energy is over here, you want it to be cold because you want to give the energy to the environment to help it react. So that's kind of the thermodynamic part of it. Alright, remember Kc, Kp, Ksp, Keq, just straight up K. All of those, Ka, Kb. They all mean the same thing, equilibrium constant. Now, lowercase kind of cursive K is the rate constant. That's what we just talked about. Capital K, like, I don't know how to even say that. Normal fonts, it's not cursive. That's equilibrium, okay? K is always equal to products over reactants. The larger the products, the more we favor the products, right? So at K, we're going to the right. Sorry. If K is large, that's because P is large, we're going right. If K is small, R is large, we're going left. A lot of this I feel like we've said the past week or so here. Yeah.
What about Q?
I'll get to that in a second. Good question. So if K is greater than 1, we're favoring products. Less than 1, we're favoring reactants. What if K is 1? At equilibrium, right. And this all relates to that thermodynamic stuff. Delta G, and then E cell. Do you want to do real quick voltaic electrolytic review after school?
What's yeah.
I mean, so what I did actually was I copied the 2017 short answer, and I want to talk about some of those. I think there's a cell in there. All right, anyways. Q is also products over reactants. What's the difference between Q and K? Right. One's initial and one's at equilibrium. Q is initial, so okay, let's say we have N2 plus O2 in equilibrium with 2 NO. Is that balanced? Yeah. How would you write the equilibrium expression? K, it would be Kp, because these are gases. It could be Kc, but let's say it's Kp. How would we write the equilibrium expression?
NO concentration or whatever, NO squared.
Squared, right. So
Over.
I'm just reminding you of that.
N2
N2 times O2, right. Remember, water doesn't go in these. Solids and liquids don't go in these things. It's concentrations, aqueous solutions, and gases. That's it. You don't put solids, liquids, or water. So if they gave you initial, right? Let's say this was the question. And they say initially you had 0.1 ATM, 0.1 ATM, and 0.1 ATM, right? So here's our ice table. So let's say initially that's your concentration. You could calculate Q, it would be 0.1 squared over 0.1 times 0.1, right? Isn't that the same thing? Isn't that 1?
Yeah.
Yeah, okay, that's fine. So that equals 1. So that's what Q is. That's initial. K would be, let's say, okay, actually, let's say they give you the initial concentration, then they gave you K, and they say K is 14.5. They would ask you what direction does the reaction shift, or which species would have a greater pressure at equilibrium, right? So if you know K is 1, but they're telling, or Q is 1, they're telling you equilibrium, the value goes up significantly. That means we shifted this way. That means down here, this pressure is going to be a lot higher than those two. That's how you use these two. Again, we'll do a practice problem, if not now, after school. I'll do one with you, but like an actual AP question. But the relationship between Q and K tells you which one is favored when it's going towards equilibrium. So if Q is less than K, that means we're favoring products. Why? It's all about products and reactant ratio. So initially, if this ratio is too small, right, and then it gets larger, the only way to increase this number. So think of it this way. These two are basically the same calculation. This is just initially, and this is at equilibrium. So if initially you have a little bit of product because that's small, the only way to make that number bigger is to make more products. So then we're going to the right. And then the opposite is true. If Q is really big and K is small, the only way to decrease that number is to shift to the left to make more reactants. And if Q is equal to K, you're at equilibrium. So I'd rather you not memorize it. I want you to understand it's about products over reactants. So if your product reactant ratio is small, so you have a small number, and it's larger at equilibrium, there's no way that number can get bigger unless you shift to the right. So you favor products, and the opposite is true. Am I making sense? I know you want to do a problem probably, but we'll do one. Right now I'm just kind of reviewing concepts here. All right. So Liz, does that help for now until we do a problem here? So again, Q is initial, and they're always going to make you figure out how do you go from the initial to the final, like I just said a few times. Is this number getting bigger or smaller, and that tells you which way you're shifting. Okay. All right. So there's that. There's that. best way to do that is practice problems. So we'll do one of those later. So what about KSP and Q? All right. So KSP. Remember, if let's see, I'll just pick one of these random ones here. Let's go with Ag2CrO4. So if you have Ag2CrO4 and you get 2Ag plus and CrO4 minus 2, this is solid, aqueous. The KSP equation would be what? How would we write that KSP equation?
Squared.
AG
minus
squared, right.
CrO4.
To the first.
Yeah, and that's it.
Yeah, so that's, and if they want to know the solubility, so that's a common question. If they give you the KSP of this, so let's say the KSP is,
Wait, how'd you write the KSP equation?
oh, sorry. So KSP equals the product, so the K is the same, products over reactants, but with these, you don't put solids, liquids, or water. So this isn't over anything. It's really over 1. This doesn't go in there. So it's just your products. So KSP is just going to be products. And it's just like all the other equilibrium reactions. You take your whatever's on the product side, you multiply them and raise them to their coefficient. So Ag plus squared times CrO4, minus 2. If the KSP is 1.1 times 10 to the negative 12, so if they give you that KSP and they want to know the solubility of this salt, how would we do that? So you do an ice table. ICE, initially it's 0. This would be 2S, this would be 2S, 2S, and S. So initially there's none of that. Once it starts dissolving, you're going to have twice as much Ag plus because it's 2 to 1. You take these numbers, plug them in, or variables, plug them in. 1.1 times 10 to the negative 12 equals 2S squared times S. Or X. You can use an X. I use S because it's solubility when it's KSP. So then it would be 1.1 times 10 to the negative 12 equals
4S
cubed, right?
cubed.
Yeah. And this would be a short answer. So I said this the other day, I know, but Chi-Chi, you weren't here. The only time we multiply this by 2 is if it's a variable. If this question gave you the solubility of Ag+, so if it said the solubility of Ag+, the concentration is 1.3 times 10 to the negative 4. So if they gave you this, so they said, all right, here's your salt at equilibrium, this is the concentration of silver, calculate the KSP. Everything changes. This becomes that number, 1.3 times 10 to the negative 4. So that's 2S. This would be half of that number. So to solve for KSP, it would be 1.3 times 10 to the negative 4 squared. You would just take that and plug it in. You don't multiply it by 2 because they already gave you the number. They already gave it to you. You don't need to figure it out. This number, again, would be half of that number. So what is that? 6.5 times 10 to the negative 3? Right, because it's 0.0. Can I not do that in my head right now?
6.5 to the negative 3.
Negative 5, right. Yeah. So anyways, that's how you find KSP. So those are the two common problems. They give you the salt, ask for the KSP, give you the salt, ask for the solubility, so that you would be solving for S. And again, when I go over it, the point is to just refresh your memory. Hopefully I can find a good, I think there's one in here about KSP. Lower the KSP, what does that mean? Less soluble. Less soluble. those two sheets I had you do today, is there any kinetics or equilibrium on there? No, right? I'm looking at them right here. No, one was geometry, and the other one we went over. The other one is synthesis of alumni. Okay. How much time we got? We got 5 minutes. I need. I know there's one here somewhere. Give me a second. Okay. Oh yeah. Here. Okay. So this is exactly what we just talked about. Number 6. Number 6. Look at number 6. So this is exactly what I was just talking about. Answer the following questions about the solubility of AgCl. Value of KSP is 1.8 times 10 to the negative 10. Calculate the value of Ag plus in a saturated solution. Which reminds me, if we're talking about saturated, what does that mean? What does saturated mean? You have 3 types. You have unsaturated,
It's
Saturated and super saturated.
saturated, and then super. One of them's at equilibrium. Which one is it?
Saturated.
Q equals KSP at saturated. What about these two?
the saturated is one. No. Yeah, two is less than.
Less than KSP, Q is greater than KSP. So what this means is if you have AgCl in equilibrium with Ag plus Cl minus, when this is at equilibrium, the concentration of these will equal the KSP. Is that it? 1 times 10 to the negative 8?
Yeah, wait, no.
No?
1.8 times 10 to the negative 10.
So at equilibrium, the concentration of these two will equal KSP. So in other words, these KSP equations are equilibrium concentrations. That's what K stands for. So initially, if you have the same concentrations that equal KSP, you're already saturated. If these two numbers multiplied together are less than the KSP, then that's going to be initially not at equilibrium. You have to increase their concentrations to reach that number. So if the question was to give you concentrations, and when you plug them in here or multiply them, it's less than that number, that's what that means. And if you have too much of these, you're over your KSP, that's where precipitation happens. So this KSP equation is at equilibrium. If these two are bigger than that number, when you multiply them, you're going to precipitate until it reaches equilibrium. And if it's less than, you have to add more until you reach equilibrium. So back to this question here. The value of Ag plus in saturated solution of AgCl in distilled water. So how would we do that? We would just solve for this, which would be S squared. So at equilibrium, it would just be solving for those. So that would be X squared or S squared. That is the concentration at equilibrium. Since it's a 1-to-1 ratio, it's just S times S. So you would take the square root, that's the answer to the first one. The second one, the concentration of Cl minus is 0.54. What is the molar solubility of AgCl in seawater? I'm kind of out of time. Not kind of, I am. We'll just pick up with this after school. So, I hope that was useful to remind you of, oh yeah, here's the kinetic stuff, some equilibrium. I will find some practice problems that we can do. So we'll go over the multiple choice. Probably all we'll have time for is those 30 multiple choice to go over, and then the practice kinetic and equilibrium problems. That's probably all we're going to have time for. But if there's something you want to do, please tell me. But try and tell me before or after school so I can find practice problems or have a plan.